Hello everybody, this is the LT Spice analysis of exercise 3.56 from the textbook Engineering Circuit Analysis. And we did a mesh analysis and a nodal analysis. Now we're going to do the LT Spice analysis just to double check our answer. So I'm getting it based off the 10th edition of that textbook, this problem. So we're going to go to New Schematic, go to File, New Schematic. And then what we're going to do is we have a current source of 25 amps. So I usually press the P button, or if you don't want to do that, you can go to Edit and then go to Component, which your shortcut is pressing the P button, and then go to Current, which is this one, or if you can't find it, just type it in. So double click on that. This current is going up, so I'm going to press Control R to rotate it. Control R, again Control R, rotate it up, and this is 25 amps, so I put 25, and then we have 1, 2, 3, 4, 5, 6 resistors. So we have one resistor over here, one over here, and then another one here, another one here. Control R to rotate it. To get to the resistor, I just press the R button, or you can go to Edit and click on this to get the resistor. So, but we don't need it right now, so I'm gonna right click. We already have our resistor, so I'm gonna right click to exit out. And then this resistor is 1 ohm. So I'm gonna right click on this value right here to put 1 ohm here, and then right click on this value right here, put 2 ohms, right click, 5 ohms, right click, 4 ohms, right click, 4 ohms, right click, 4 ohms. LT Spice is not going to work unless you have a ground, so you can press G, or you can go to Edit and place the ground. Place it anywhere in the bottom. And then we're going to need to connect these with wires, so you can press W. I love shortcuts, so that I don't have to keep pressing this, but if you don't know the shortcut, you just go to Edit and go to W to draw the wire, and then left click to start. And then connect your ground. Make sure the ground is connected. Make sure you have that blue dot, because if you don't have that blue dot, that means your ground is not connected and you're not going to get the results that you want. Connect these resistors, are in parallel. All right, looking at my problem, I think we have all of our values. Now we need to define the nodes. So the way to do that is by, let's see, N, this net, label net. You can click on this, or you just press, your shortcut is going to be N. And then I'm just going to put V3 underscore 3. For this one, this node right here is going to be V3. And I'm going to put V3 in all of them, but I'm going to edit it. So right click, and then it's going to be your V2. And the reason why I'm naming it this way is because that's how I named it in my nodal analysis. So this is the way that we're going to name it. So now we're going to do an analysis. The question asks for the value of I1, which is going through here, and I2, which is going through here. So in order for us to get I1 and I2, we're going to need to put a voltage of 0 volts. Since the current is going left to right, we want the current going into the positive terminal. We want the currents going into the positive terminal. Let me clean this up real quick. Put V1 somewhere else. Then relabel this node v_1. And this is gonna be our we're gonna use this to pretty much measure I1 over here and I2 on this side. And in order to do that, you're gonna want to put 0 voltage, and you want it to be a perfect wire. 0 voltage shows you that it's a perfect wire without any voltage drops. And since the current is going left to right, we want the current going into the positive terminal of these voltages. That will allow us to measure I1 and I2. And I'm just gonna, I guess, rename this I1 and I2. And then V3 is another thing that they ask for, so we already have that labeled. Next thing that we want to do is we want to press run, click on DC op PNT, and press OK. .op. Once you see that .op, oops, it's not letting me run it. The reason why is because these two are the same. So we're just gonna put I_1 on this one, I_2. So you don't want to name these two the same. So once you have that .op right here, you could also do it manually. Let me delete this by pressing in Spice directive and put .op. I'm just gonna do a DC analysis. You can put it anywhere right there. And now what you're gonna do is you're gonna run it, and then as you guys can see, V1 is 15.33, which matches with our nodal analysis. V2 is 5.333. V3 is what we want, is 2.67, which is over here, V3, and the current at I1 is, let's see, I1, yep, okay. I was looking at this one, it says 25 ohms, but this is the I1 that we want. I_1 is 9.67, which is right. And I2 is 2 ohms. I mean, not 2 ohms, 9.67 amps and 2 amps. So we got our answer right here. And then what we're going to do is copy. And then put a text. And then put that right there. Your professor may want you to annotate it. I know mine wanted me to annotate it and putting it in a Word document on like a report type of a document and annotate it, you know, circling the values that was desired and putting it in a Word document. So putting it on a text file or on a text like this is super helpful. We have our V3 2.6666 volts. I1 is 9.6667 and I2 is 2 amps, which is what we want. So this is the LT Spice analysis of exercise 3.56, just to double check our answers. And again, we need to put these two voltages of 0 in order to get I1 and I2, and just to isolate I1 and I2 to measure it. I should just probably name this I instead of I1. This kind of makes it a little bit confusing, so I'm going to name that part I. Yeah, I think that's pretty much it, and thank you for watching.